Okay, welcome back. We're going to be sketching some reciprocal trig functions. So let's have a look, sketching y equals sec x minus pi on 4 in this domain here for x. Okay, so just in the last video I talked about the asymptotes, and we had y equals sec x, y equals cosec x, and y equals, not tan, better up tan, y equals cot x. What were the asymptotes for sec x? They were pi on 2 plus k pi. Cosec were just k pi, and cot x was k pi. Okay, so one way you might want to remember it is that because these are the cut functions and that they have k pi asymptotes, might be a handy way to remember that those have they're the cut functions with k's. Sec x, it starts with s and has just a different sort of pi on 2 sort of thing. So that might be a handy way to remember those, and that's exactly how I do it. Okay, so what I'm going to do first is write down what the asymptotes are y equals sec x are, and then what we're going to do is have a look at what the transformation does. So y equals sec x has asymptotes of what? Well, we just wrote it down, pi over 2 plus k pi. Okay, so if we wanted to think about it sort of in this general range, we've got negative pi on 2, pi on 2, 3 pi on 2, etc. Okay, and if I go down this way as well, negative 3 pi on 2. So they're the sort of asymptotes. And what this is a transformation of the graph of y equals sec x, but moved by pi on 4 to the right. Okay, so y equals sec x minus pi over 4 has asymptotes of, so if we add pi on 4 to all of these, what do we get? Okay, so it can be a little bit tricky doing your sort of pi on 4s, but let's have a think about this. Negative 3 pi on 2 is negative 6 pi on 4. If we add pi on 4, it's negative 5 pi on 4. Okay, negative pi on 2 is negative 2 pi on 4, so that'll be negative pi on 4. If we add pi on 4 to it, this pi on 2 is 2 pi on 4, so if you add pi on 4 you get 3 pi on 4, and I won't keep going because then it goes out of this domain and that's out of the domain here. So all we're really looking at inside this domain is these two asymptotes there. So they're asymptotes, so let's go ahead and sketch those on here. So we'll just make it, we only need to go from pi to negative pi, so let's put pi there, negative pi on 2, and pi over 2. So that looks pretty good, and this will be our 1, this will be negative 1. Okay, so let's put these things on here. Let's put our asymptotes of, again, sorry about the lack of straight lines, negative pi on 3, 3 pi on 4, that's 3/4 of pi. So we'll draw those on there. Just label those asymptotes, 3 pi on 4, x equals negative pi on 4. There, we've labelled our asymptotes. Fantastic. At this point you need to, there's some key things. Always label endpoints. Always label x-intercepts and y-intercepts. Okay. So firstly, let's figure out what our endpoints are. Okay. What happens when x is equal to pi? When x is equal to pi, y equals sec of pi minus pi on 4, so that's sec of 3 pi on 4. Just let me check that, pi minus pi on 4, yep, that's 3/4 of pi, which is equal to 1 over cos 3 pi on 4, and just always consult my circle. 3 pi on 4 is here, okay, which is symmetrical to that one there. That cos of that point there is root 2 on 2, and so if we go in the negative direction, because it's this negative x direction here, we'll get 1 over negative root 2 over 2 for cos 3 and pi. So what that's equal to is negative 2 over root 2, and if I clean that up, times by root 2, is that just a negative root 2? Change that to an equals. Negative root 2. It is 2. It just cleans up to that. And so let's just put that point on here. So if x is equal to pi, I'll just get my red pen out. Negative root 2 is negative 1.4, so at pi it'll be negative 1.4, so right about there. Okay, so there's our endpoint. Always make sure you put that on there and label that. So we'll just label that pi and negative root 2. Always use exact coordinates. There's our endpoint there. Okay, fantastic. Let's find the other endpoint. X is equal to negative pi. At negative pi, y equals sec. Right. Negative pi minus pi on 4 is negative 5 pi on 4, which is equal to 1 over cos negative 5 pi on 4. And let's have a look at this. Negative 5 pi on 4, so it goes around in a negative direction. 4 pi on 4, 5 pi on 4, in fact it's the exact same spot. And so we know that's also equal to negative root 2, which is very, very handy. So let's put that point on our graph as well. We've got negative pi and we'll have negative 1.4, so it's about there. So there's our other endpoint there. And I'll just label that as well. Where's our graph going to go? I'll just put it on this side because there'll be nothing there. So that's negative pi and negative root 2. That's the coordinates of that endpoint. Okay, I'm just going to save a bit of time, but you will do this. You will find your x-intercept and you'll find your y-intercept just by setting y is equal to 0 and x equal to 0. Okay, you'll do that. I'm just running out of time and space, and so I'm just going to go ahead and do this. Okay, you can also find out your maximum and minimum points because they'll always occur exactly halfway between your two asymptotes. So halfway between your asymptotes is here. And what will the y value be? Well, there's no y transformation here, and so it's just going to happen at 1, and it's just going to be right bang in the middle, so it'll be right there. And the other ones, oh, and how did I know it's going to be up this side? Just by looking at this endpoint here means that it must, this asymptote is going to come up like that and stop there, and this one is going to be going, well, what's the midpoint here? It's going to be halfway in, which is here, and it's going to go to 1, so that's going to be your turning point there. And so what does this look like? It's going to come up in this direction and go back down and stop there. Okay, and similarly here, I'm just going to go, try not to go through that, down to your turning point. Oops, I'll start that again. It's going to come down to here, hit your turning point and go back up like that. And so this is the graph of y equals sec. What did we say? X minus pi on 4. Important things: label your asymptotes, label your endpoints, and if I was good and you will be good, please label your x-intercepts. So in fact you won't have any x-intercepts, and y-intercepts here I would like you to find those y-intercepts. They're sort of minimum requirements whenever you're sketching a graph. I won't draw any of the other two functions, but they're the general tips. The tips are: write down the asymptotes of your the original function, the base function, figure out what the transformations are, and just apply that transformation to find out your asymptotes, and then find out your specific points, and that from those points you'll be able to draw the graph, no problems at all. Specialist maths only requires simple transformations. Okay, you're not going to get anything like y equals negative half sec, 2x minus pi on 10, anything like that, plus 1 or anything. You're not going to get crazy ones like that. You'll only ever get simple transformations like moving by pi on 4 or sec 2x, y equals sec 2x, or y equals 2 cos, cot x. Simple transformations, so 1 or maybe 2. So make sure you understand how to do the basics and how to apply transformations.